All right, so here is, like I said, we're just going to run through these real quick. If you got it right, put a check. If you got it wrong, put a little X. And if you figure out why you have it wrong, awesome. If you don't know why you got it wrong, just ask and I'll run through it really, really quickly. All right, so number one should just be calcium hydroxide. Calcium hydroxide. Number two should be silver chloride. Why is there no Roman numeral in that? Silver's an exception. Number three should be iron 3. Iron 3. And what's the polyatomic? Chromate. Very good. Iron 3 chromate. Now, number 4 may get some of you. This is copper what? 2. Very good. Copper 2, not copper 1. This is copper 2 oxide. All right, number 5 should be sulfur trioxide. Let me ask you something. I get this every year. Why is this not sulfite? Sulfite has to have a charge. Very good. There's no positive or negative anywhere in this thing. Okay. All right. Number 6, potassium. And what is this polyatomic? Hypochlorite. Potassium hypochlorite. All right. Number 7, zinc oxide. Why is there no Roman numeral in that one? Zinc an exception. Very good. Number 8 should be iodine trichloride. Iodine trichloride. Number 9, I like this one. Ammonium hydroxide. You didn't even have to. All you had to know was the name of the polyatomic on that one. You didn't have to think about it. Ammonium hydroxide. All right, number 10, cobalt 3 fluoride. Cobalt 3. Now, if you got this one, you deserve a high five. So high five yourself if you got this one right. This is a tough one. Rhenium 6 sulfate. Rhenium. How many of you got 6? Very good. Real quick, let's look at that one because I feel like some of you may kind of have a question. It was ReSO43. So again, you know it's rhenium, but how do we get the 6? What's technically sitting right here? A 1, so I'll pull back. That's the 1 minus. I pull the 3 up here. And again, this is where you have to know your polyatomics. What is sulfate? 2 negative. Not 1. So you got to double both of these. And so that turns from a 3 to a 6. And that's from a 1 to a 2. So it's rhenium 6. Okay. That's a tough one right there. All right. Number 13 is dinitrogen monoxide. Dinitrogen monoxide. I did. My apologies. Number 12. Potassium. And what's that funky polyatomic? Dichromate. That's one of your only exceptions to the whole prefix rule because that's just the name of that thing. You can't change it because is there such thing as just chromate? And that's not just chromate. That's dichromate by name. All right, number 13 again, dinitrogen monoxide. Number 14 is vanadium 3 iodide. Vanadium 3. Did you get the Roman numeral in that one? Okay, make sure you did. And the last one should be gold 1. Nitrate. Gold 1. Just out of curiosity, how many of you got all of those right? Vanadium 3 iodide. If you missed it, do you know why you missed it? That's the whole goal of this. Any questions specifically? I don't mind answering any of them. Yes, ma'am. Jamila. Copper is not an exception. Zinc, cadmium, and silver. Cadmium. And aluminum. But aluminum is in group 13, so I never really counted as one because it's always going to be a 3. Yep. Any other specific questions? All right. So here's what we're going to do today. Tomorrow when you take your test, let me give you a piece of advice. And I always used to say this is like a little mnemonic device because this is how I always did it. And it always worked for me. To myself, I always said, pray for prefixes. And I'm only talking about these like crap. I'm only talking about the name to formula. These right here. Why do you want to pray for prefixes? They're super easy. So here's a little hint. Tomorrow when you get the test, start with those first. Do every single one of them that has a prefix and go ahead and get those over with. Get them out of the way and get them right. Because those are guaranteed points if you do it correctly. Guaranteed points. So let's go through and let's find the ones with prefixes. So number 18, carbon tetraiodide. And I'm gonna change screens, and I want to show you what some of you in this class did last time. It was carbon tetraiodide, correct? I got this for some of you. Why is that wrong? What did they do? They swap the prefixes, okay? Leave the prefixes where they are. If they're attached to the element, they belong to the element. So what is carbon tetraiodide? Very good. Guys, that's already several points. And you don't freeze your brain on the hard ones and get to the easy ones and mess them up. Start here. All right? Let's go down and find another one. Number 22, phosphorus trichloride. So what's that? PCl3. Don't miss it. You've already got 2 right. Start off on PCl3. Start off on a good note. Number 24, dinitrogen trioxide. So what's that? N2O3. Number 26, dicarbon heptahydride. Very good. That's one that we don't use a whole lot. Hepta is what? 7. And then number 29, nitrogen triiodide. Ni3. Very good. Ni3. Okay, Ni3. Yes, ma'am. No, what you got? Throw it at me. No, I'm going to do all the rest of them. Yeah, so my hint was tomorrow, do those first. Because if you know how to do those, let's see, that's 1, 2, 3, 4, 5. You've already got guaranteed 5 of them correct. Start there. Start off with a positive note. Because if you read this and you're like, crap, your brain shuts down and you're like, I don't feel like doing the rest of this. Go ahead and do the easy ones first. Get them out of the way and get those guaranteed points. Yes, ma'am. I have tried my best. There are several different types. Some of them are all covalent. Some of them are ionic. Are group 1s and group 2s with regular nonmetals. Some of them are group 1s and group 2s with polyatomics. Some of them are transition metals with other nonmetals. And some of them are transition metals with polyatomics. I have tried to make them equal across the board. That way you're not doing a lot of one or a lot of the other. I try to make them like 2 of each kind is my goal. Now, it may not be that way, but that's my ultimate goal. So you're seeing the whole gambit of every type. Is that fair? Okay. All right, so let's go back. And now, Jamila, you asked about 16 specifically. Sharon, I think it was you that did a really good job of this. And I want you guys to start doing this on all of them and to the point where you can do it without even writing it down. Because here's my fear. A lot of you try to do it in your brain, and your brain doesn't translate to your hand very well. If you will write it down, your eyes will do the work and not your brain. So here's this is, again, something I want to see you do tomorrow. So do it on every ionic problem. Now notice we have all the ones that are left are all ionic. How can you identify the fact that it's an ionic compound? It's a metal and a non-metal, or not a metal and a polyatomic. That's the key. Is you know the rest of them for sure are going to be ionic. So you've got to have a metal and a non-metal at this point. So let's start with what we know. The first thing, and I'm going to come back to this, is that you just told me that they're ionic. What things make up ionic bonds? Ions. And what are ions? Very good. Charged atoms. Now, what is a charge? What's the sign of a charge? Positive or negative? And I told you this yesterday. What made me the most upset with you guys is that whenever you wrote the answers to this type, I saw pluses and minuses all over the place. Again, go back up and look at the first 15. Do you see any positives or negatives anywhere in any of those problems? No. So don't you make up some brand new way to do it. Do you see any number in any superscript position? No. So don't make stuff up. Continue with the system that we have. All right. So let's go here. So let's start with what we know. Calcium is an ion, and how do you know calcium's charge? It's in group 2. So what's its charge? Calcium 2+. So I want you to physically write that down. Physically write down calcium 2+. Now, if you want to, I mean, I would, if that way you know where we're going with this. Now, you know calcium's 2+, and then this was probably the one that got some of you. Nitrite. If you don't know your polyatomics, this is going to mess you up. Now, what do we put polyatomics in? Parentheses. Now, and I noticed a lot of you doing this. Does the whole entire polyatomic go in it? No. Something goes outside of it. What goes out? The charge. Now, what is nitrite? 2. And the charge is 1 negative. Now, the next part, I want to see you do this on all ionic compounds. This next part you don't have to do if you don't want to, but I want to see this. Do you agree that your eyes are now doing the work and your brain's not doing it anymore? This is going to allow you to see what to do and not think of what to do. So what do we do with those two things? Crisscross. So here's my next question. Do I have to keep my parentheses to continue protecting that polyatomic? Yes. What am I protecting it from? The 2. Very good. So here's the final answer. CaNO2 parentheses 2. Now do you see what I mean by your eyes are doing the work and not your brain? And that's where some of you have a disconnect. If you'll write that down, I promise it'll make it 10 times easier because you can see it. You know what it is. All right? Any questions on that one? Next, calcium bromide. Again, the exact same thing. Write down the element with this charge. What group is calcium in? 2, so it's a 2+. Now, this is bromide. So what does it look like? Is it Br, or is it by itself, or is it with a lot of other things? It's by itself. Now, and this is where I noticed a lot of people kept messing up. They would just write the charge on the metal, and they would completely forget. But we just talked about this. Ionic compounds have ions. So both things have to be ions. As I have it written right now, is bromine an ion? As it's written right now. No, there's no positive or negative on it. How do I know what the charge of bromine is? It's in group 17. And what's the charge of all group 17s? -1. Again, let your eyes do the work, not your brain. What do you do with those two things? Crisscross them. Again, this part you don't have to do because you know what to do there. So your final answer is CaBr2. CaBr2. Any questions on that one? All right, the next one, number 19. I'm going to bounce pages real quick and ask you this question. So it's 10,4 iodide, right? Okay. Listen to my question. If this were the question, what is the correct answer for where the 4 initially belongs in the beginning? 1A, 2B, 3C, 4D. Hold up fingers. 1A, 2B. Where does the 4 initially belong? In the very beginning, where does that 4 technically belong? Not 5. That's impossible. Not the answer. Not the answer. This 4, where does it start? B. Starts off at 2. Because again, the Roman numeral is the what of the compound? The charge on the metal. Because this is technically a charge 2, but the 4 belongs to the metal, not the nonmetal. Now let me ask the follow-up question. What if this was the very next question? Where does the 4 belong in the correct final formula? 1A, 2B, 3C, 4D. Where does the 4 belong in the final answer? C. Okay? Again, because what do we do with this charge? We bring it down, we crisscross it. Okay, so let's go back and let's look at it now. So we know that it's going to be SN4 plus. Now that little example I just gave did not talk about the iodine. I wasn't concerned with that. I was just talking about the 10. But iodine is in what group? 17. So what's its charge? -1. Again, write this stuff down so you can know what you're doing. And so what's your final answer? SNI4. All right, number 20. Copper 2 sulfate. Again, who does the 2 in the Roman numeral belong to? Belongs to copper. So I'm going to write it down for the charge. So I've got Cu2 plus. And then again, I can't help you there. You have to know that. What do I put sulfate in? Parentheses. So I've got SO what? 4. What goes outside? 2 negative. Now, you can do one of two things. And I'm going to change screens and I'll come back to that. You can do one of two things. So I've got SN. What SN was it? What was it? Was it copper? My bad. All right, so Cu2 plus, SO4 2 minus. You can do one of two things. You can do this, and you can say Cu2 SO4 2. But if you wrote that, and several of you did this on the last test, why is that wrong? It's not simplified. It's not reduced. But let me ask you, is this correct? Keep wanting to write S. I reduced it. Very good. Say that again. It's not sulfite. It's hyposulfite. Sorry, as soon as I got that out of my mouth, I said that's not right. But I just changed the name of this thing. I changed it to copper 2 hyposulfite. Again, what do these parentheses do? They protect it. You can't do anything. So my way, the way I say it, the way I do it, what does a 2 plus and a 2 minus do? They cancel. When they cancel, do I still have to keep the parentheses? No, get rid of them. Now let me ask you this, and again, this is just so you'll know. Will I mark it wrong if you leave them? No, I will not do that. But let's get to the part where you're doing it correctly. Okay? All right, number 21. A lot of people always struggle with this one. Every year I give it, and people they don't know what to do with it. Same rules apply. Yes, ma'am. Yes. Aluminum. What group? 13. So what aluminum's charge? 3 plus. Okay. Oxygen. What's its charge? 2 negative. Again, just out of curiosity, just for teaching, do you like seeing this? Does this really help? It has to help. There's no other way, but it can only do you some good. Okay. So what do we do with that 3 and what do we do with that 2? Do they cancel? No, they don't cancel. We got to do something with them. So we got to do Al2O3, and that's our final answer. Al2O3. Al2O3. This is just so I know. Did anybody watch the video on the homework last night? Good. Did it help? Again, if you don't have to, it's there for you to utilize. I'm just curious if I need to continue wasting my time sending it out or what it's worth. All right, 23, iron 2 sulfide. Okay, the 2 again belongs to iron. So I've got Fe2 plus and S. Now, what group is S in? 16. So what's this charge? So what happens to those charges? Cancel, and that leaves me with FeS. Okay, FeS. Any questions on any of those prior to this? Anybody? Okay. All right, scroll down as much as I can. If it's an ionic bond, it has to have a charge. I don't know if I understand your question. Try to give me an example. Like, I want to answer your question. Uh-huh. Every atom has to have a charge. don't know if I don't know if I understand your question. So, like, if I wrote this, if you're telling me that there was nothing there, is that what you're asking? Well, if this is ionic, there has to be something right there. And the way you get that is from the group number. That's impossible. It can't be. Like, there has to be a charge on every element. Like, there's no such thing with an element without a charge. Now, if it's covalent, you don't have to worry about these because they'll have prefixes, right? Just name what you see. Don't worry about those. Pray for prefixes. But if it's an ionic bond, which means, do you agree that iron is a metal? Do you agree that sulfur is a non-metal? That means it's ionic, which means it has to have a charge here and a charge here. How did I know that this was iron 2? It had that Roman numeral right there. It told me that. Now, the reason I know that sulfide was a negative 2 was because it's in group 16. And all group 16s are negative 2. Now, do you know why they're negative 2? Why? And it needs, very good. That's the perfect answer. I just want to make sure that you knew why it was negative 2. All right. The next one, lithium nitrate. So we've got lithium. What group is lithium in? I'm sorry, Emma, you had a question. Go ahead. No. A lot of them, like titanium can have 3, iron can have 3. Remember, they can have multiples. I'm trying to remember. Hold on, let me pause this and let me go look. All right, so does that help, Emma? Does that make sense? All right, because like I said, they're not all going to be 2s, but a lot of them can be 2s. All right, now what group is lithium in? 1, so it's a +1. And then again, you just got to know what nitrate is. And nitrate is NO3 negative. And what does a 1 plus and a 1 minus do? Cancel. Very good. So I've got LiNO3. All right, we've already done 26. 27, iron 3 acetate. This one kind of gets a lot of people just because it looks so weird. So iron, and it tells us it's a 3. I've come to realize that acetate is a lot easier to recognize and name than for you to write the formula. A lot of y'all mess the formula up all the time. What is the formula for acetate? Very good. C2H3O2. And what's its charge? 1 negative. Very good. And this one just kind of throws everybody for a loop because it is so long. Most polyatomics don't include all of those things. Now, my first question is, do the charges cancel? Do I have to keep my parentheses to protect it? Yes. So it's going to be Fe parentheses C2 H3 O2, and then it is 3. Iron 3 acetate. Okay. Number 28, titanium 3 phosphide. All right. Titanium is Ti 3 plus. Phosphorus. Don't miss this one. What is phosphorus's charge, and how do you know? What group is it in? Group 15. What's all 15s? 3 negative. So what happens to your charges? They cancel, which leaves you with TiP. Leaves you with a tip. Okay? And then the last one, barium nitrate. What group is barium in? Group 2. So Ba 2 plus nitrate NO3 negative. And so that gives you Ba NO3 2. NO3 2. All right. Now, real quick, very last thing, I just want to make sure. Now that we've gone all over those, I don't want you to not remember how to do these. Is everybody good with these? Okay, all right. Again, I expect hundreds tomorrow. Hundreds. Yeah, hundreds.